Hello everyone, this is Sai Sri and welcome to my channel. So in this video, let us see what is meant by Kirchhoff current law, which is nothing but KCL, and two problems on that. On further videos, I will upload more on Kirchhoff current law problems. First of all, let us define what is meant by KCL. The sum of currents leaving at the node is equal to the sum of currents entering at the same node. So if you consider a node A, so here the two currents I4 and I5 are leaving. Here I1, I2, I3 are entering. So these two currents sums are equal. So if you consider this, I1 plus I2 plus I3 is equal to I4 plus I5. So these two currents are leaving, these three currents are entering. So these two sum are is equal to 0. And we can also define as the algebraic sum of all the currents at a node is equal to 0. So now let us see a problem. So let us consider a circuit. So here we can see Ix, Iz and this 2 amperes current are flowing in one direction, and Iy and 2 amperes currents are flowing in another direction. So from this, by applying KCL, so what does KCL state? It states that the sum of currents leaving is equal to sum of currents entering. So in order to solve this circuit by using KCL, so first of all let us consider Y. It is a node. So from this node we can see that the two currents are entering. They are Iy and 2 amperes, and three currents are leaving. So 10 amperes, Ix and Iz are leaving. So according to KCL, sum of currents leaving is equal to sum of currents entering. So Iy plus 2 is equal to Ix plus Iz plus 10 amperes. So from Ohm's law we have V is equal to IR. From this I is equal to V by R. So Ix is equal to V by 5. What is the resistance here? 5 ohms. And Iy. So if you see here, the current is flowing from negative to positive. So when the current flow from negative to positive, we take the symbol as minus. So minus, voltage over here is V by 2. And we have another current, that is Iz. So Iz is equal to V by, so what is the resistance here? 4 ohms or amperes. So now substitute in place of Iy, Ix, Iz these values. So Iy minus V by 2 plus 2 is equal to V by 5 plus V by 4 plus 10 amps. So by solving this, we can get the voltage over 2 ohms. V by 4 plus V by 2 is equal to minus 8. So taking LCM, 4V plus 5V plus 10V is equal to minus 8. So from this, V is equal to minus 8 into 20 by 90. So that is equal to V by minus 8.42. So we got the value of V. So from above equations we have Ix is equal to V by 5. That is equal to minus 8.42 by 5. That is equal to minus 1.684 amps. And next Iy is equal to, that is equal to 8.42 by 2, 4.21. Next Iz is equal to minus 8.42 by 4 is equal to minus 2.1. So in this way we can calculate the current values by using KCL. Let us see another problem on KCL. So the second problem is very easy. If you understand the first one, then you can solve easily. So this is the node X. So at node X, the two currents are entering and one current is leaving. So by applying KCL, you can write 5I1 plus 3I2. So this is I1. That is equal to current leaving, I. So here they have mentioned that I1 is equal to 3 amperes, I2 is equal to minus 2 amperes. Now substitute the values. So by solving we can get I is equal to 9 amperes. So in our next videos, let us see more problems on KCL.